Hello guys, today in this video I'd like to demonstrate how to get the elevation data in QGIS without digital elevation model. It can be really useful feature, a nice shortcut for lots of you I think. By browsing random YouTube videos I came to conclusion that there are basically two ways of getting elevation data in QGIS. They are admittedly quite external, to be honest, because we have one option which plays around digital elevation model or shuttle radar topography mission files, and another one is simply extracting elevation data from Google Earth and it further conversion to GPS file. Like shown pretty much in this video, we need to draw the line over the area, and next we can export this multitude of points to our file. Today I'm going to show, I think, quicker method which would allow us to get the elevation data in QGIS. Let's get started then. Before I show you how to make it quickly in QGIS, let me compare two files between each other based on the video you see in front of your eyes made by GeoDelta Labs, which shows how to extract the elevation data from Google Earth. Let me open the Google Earth, and instead of marking the multiple points, let me draw the path which will contain only two points. So I will basically play around this area today. So this is the road crossing which I'm going to consider. So let me start my line here and let me finish my line there. So my line already has 2 points. Let me save it as the test path, and style and color may remain the same. And let's follow the videos considered previously in YouTube. We are saving this place as and save it as the KML. So already my path has been saved successfully, and now I should go to the GPS visualizer / elevation, where I can choose the file I'm already working on, test path. Let's open it and hit convert and add elevation. After waiting a while, my data is downloaded and I can easily place this data to the folder. Alright, so my GPX file, my converted GPX file is already in the target directory. Let me do the same in QGIS. Pick up exactly the same 2 points in exactly the same place, which happened in Google Earth. Before I do it, let me double check the exact location of these two nodes, which produce the following line. Compare them with the location in QGIS. So this is exactly the place where this line has been made in Google Earth. So let me do quickly one thing in QGIS layer, create a new temporary scratch layer. Even without the name, it will be the point layer, and the system WGS84. Alright, so let me create these 2 points where one falls here and another one falls there. And what will happen next? I can save this feature as the KML file. So let me save this file as the KML. Let me save it as the test path2 in KML. Keep the CRS as WGS84, and we have effectively nothing because it was just the scratch layer, and we have the test path saved. So we can back to the GPS visualizer right now. In the GPS visualizer, back to the elevation section again, and instead of the first file, choose the second one right now, and simply repeat the task. After we've got everything, we can save our file. Obviously, here you've got the onlook on your GPX coding, but I will back to it in a minute. Let me save this file first and store it in the same folder like I did before, right? Okay, so I've got these two files already saved. Therefore, I can use any software which is able to open the coding version of GPX file. It can be Visual Studio Code or similar. I will use the Notepad++ for this purpose. Okay, so what I could do right now, just simply drag these two files over the Notepad++ and see what can we read from that files. The first file comes from Google Earth with the terrain mode switched on. So it wouldn't surprise anyone that the elevation data is quite detailed. We've got basically three decimal value of meters above the sea level at the given location, which you can read here. However, when we take a look at the path produced by QGIS, this difference is not quite big. Probably I would miss some location. Maybe I stored that dots in slightly different places with centimeters difference, but you can see that instead of 24 meters, we've got 24.2. Instead of 23.6, we've got still 23.6. So it means that we don't need Google Earth for producing the elevation for QGIS. We don't need the Google Earth at all. For extraction, just the GPS visualizer is required because GPS visualizer is capable for getting that elevation data for us without third-party tools like Google Earth. So since now you will know that you don't need Google Earth at all for that purpose. So this is the key thing of the shortcut I'm going to show you right now. Let's go back to QGIS then. In my QGIS, I can remove these two layers because they aren't needed anymore. They were produced just for the proof that Google Earth is not needed for extracting the elevation. So this whole part of the video was meant to show you that this is definitely a quicker way for getting this elevation data. Let me toggle the Google satellite and see the purpose of my today's video admittedly. Let me find some most suitable area here. Let me browse slightly here. Alright, so I can go with this shape here. So imagine that I'm an owner of this plot of land, which you already can see here. And I would like to know the elevation data of this plot of land. So it will be the basic purpose of my current job. Alright, so in my processing toolbox I can start typing grid, which leads me to the option create grid. Grid type should be point, and my current step will be select extend on canvas. So I need to define some box within which the grid will be generated. And another important stuff is the horizontal and vertical spacing. As default, the value shows 1, but this is extremely detailed value and might not be generated correctly. So maybe your QGIS will be crashed, or eventually you will get far larger file, too large for conversion in GPS visualizer. So bear that stuff in mind. I think the 10 will be the most optimal here. So let's go with 10. You can try 5, will be still good, 8, etc. etc. If you put 20, it may work, but for larger area, not just single plot of land or residential area, because this is quite small area to generate a decent elevation data. Grid CRS may stay as it is, so it looks like everything is fine at this stage. Make sure that this is the unit here is correct. Usually we will generate the stuff in meters and hit run. After waiting a while, the algorithm has been processed, you've got the point grid layer already prepared. And admittedly, this is an analog thing to Google Earth where you used to draw the line like this and then like that in order to getting the elevation data. Now you don't need to do it anymore because you can simply generate the grid in your QGIS, right? So your another step will be surely export this data, save the feature, and save it as the QML file, the same way as you could do in Google Earth. Your file name will be, let me call it like elevation. Click save. Make sure that your CRS matches the K4 markup language CRS, which is WGS84. Otherwise, your data won't be saved properly. You will get it dissipated around the globe, which won't be good. Hit OK. Wait a minute, and as you can see, your new file has been generated. So in this case, you can remove the grid and go back to your folder, or not necessarily to the folder. Go to the GPS visualizer. Maybe this is the one thing I have forgotten to tell you, namely the data attribute table of this generated file, as we had simply nothing with the pure grid point layer. After the export to the QML file, we have received quite a lot of columns. Basically, you don't need to do anything with them. You can alternatively remove them at the stage of saving as the QML file, but don't worry about them that much. I think now is the moment when you need to enter the GPS visualizer slash elevation website and load your file. In the GPS visualizer slash elevation, you've got the place to loading your file, and as you can see, the option is convert and add elevation. So this is the one which you will use for the purpose, and this is the one which has been explained most of the times by showing how to extract the elevation data from Google Earth. However, before I jump to this section, I need to explain you this smallish map here, which represents all the shuttle radar topography missions available worldwide, and this is admittedly the stuff which has been utilized by GPSvisualizer.com in order to provide the elevation data for any place around the globe. So it's good to get acquainted with this map, by the way. But now let me do the process. So I will choose the file I saved recently from my QGIS. The file is elevation. So open the file and hit convert and add elevation. Because the file is quite large, I need to wait a few seconds or even more until the data is converted properly. Looks like everything is fine, so I can download this data already here. But before I do it, let me explain you the shape of the XML code itself, which does look differently than the XML code converted straight from Google Earth. The primary difference is the description, which contains a lot of robust session, which basically we don't need it. So the description tag includes only unnecessary text, which basically makes our file larger. But again, don't worry about that. Let's download your file and import it to the QGIS. Before I get to QGIS, I just would like to move my file to the correct directory, which is here, and at first glance we can see that the size of the file has increased from the previous KML file. It's not a problem, as the GPS visualizer can manage with files up to 10 megabytes, but because of the description tag shown recently in the GPX code, we can see the result clearly here that the overall size of our file has increased over 1 megabyte. It's obviously not an issue, but just out of interest you can be aware of it. So let's change the name of the file to the elevation GPX, and now import this file to QGIS. We are in QGIS again, and we can import the vector layer by choosing layer from the main bar and option add layer. Next, add vector layer, and select the GPX file from our directory, right, which is here. But I will ditch this option right now and show you a quicker way to do it. Instead of going through all these steps, you can simply open the folder where your file is stored and drag this file onto the QGIS map canvas. When you see the plus and copy, it means that you can simply drop the file and the result will be exactly the same. The file will be imported, but in the case of our GPX file, we have more than one layer. They all are listed already in the panel, which you can see in front of your eyes. However, most of them are empty, so we won't use them. The only one layer which contains something is the waypoints, and these are all the points which comprise of this grid point layer prepared for the given area. And therefore, instead of select all, which we could do on a normal basis, we will select just this one layer. Hit OK, and our layer has been imported to QGIS. So all this data is in our GPX stuff here. Basically, this is our GPX file imported to QGIS. It comes within the group. We can move this out of the group, but it's not necessary step to do so, but I will do it. Now I can remove the elevation file, the QML file, which I have saved previously because it's not needed anymore. So let me remove this layer, keep our project as much simple as possible. So we've got the new grid layer somewhat, which has been equipped with the elevation data. You can check the stuff by opening the data attribute table. What is the most important for us? Not the description, which is which means nothing, admittedly, despite the amount of strings put here. There are other columns which also aren't needed. We just need the elevation which has been stored in this particular column, and this elevation has been assigned for every single point included in the grid layer defined for the area shown here. Alright, so we are in a good place now because we can carry on our work by using this data. So let me close this data attribute down and use another very important feature which will allow us to generate something like digital elevation model from this data. So it's also the thing which we can find in our processing toolbox. This is the TIN interpolation. By typing TIN here, you can find this tool easily. So open the TIN interpolation, and we've got some options here where we need to select the proper data. So again, I have removed the previous grid layer and I keep only the one. This is also important here. By keeping our project simple, we don't have any problems with selecting some layers here, don't have dilemmas and so on. So this is why we need to remove everything which is not needed. Okay, so we've got the elevation waypoints here, and now we need to select our interpolation attribute, which will be one of the columns considered from the attribute table. And obviously it will be ELE column because this column contains the elevation data for our grid, right? But in order to confirm our layer, we need to hit the green plus here, and this is the confirmation. You always need to do this, and you need to make sure that your criterion appears in the box below. Alright, the interpolation method may stay as it is. Important is extent, and this is something which needs to be explained. The extent must always match the vector layer used for our interpolation. Otherwise, you will have some abnormal data here. As a default, they come in one and one, and they should come in one and one when you use the same layer as considered for the vector layer. But if you, for instance, select another layer, like let me select map layer, then you see that the data suddenly changed. So this is not right. You need to have it one if you need to make sure that your selection is fine. Okay, however, another thing which comes out with this situation, the row 1 and column 1 means that our interpolation will be mono-selected at some point. The number of rows and columns included here is far too small. We need to use at least 10 rows in order to have our result quite reliable. So when you put 10 rows here, the number of columns will be generated automatically, and this is basically the amount which can be proceeded further. So bear in mind that this output raster size must be adjusted manually. The layer will be saved as an interpolated layer, and I think that's it for this. From this panel you can hit run and wait a while until the algorithm is generated and your interpolated area has been produced. That's very good. It resembles the digital elevation model at some point, but we need to explain some stuff here. Basically the coloration, which means that the darkest boxes means lowlands, the brightest boxes means highlands. So here where my cursor is already, this is the lowest part of the area considered, and this is the highest part of the region. Okay, now is the time for extracting contours from this area and make some cuttings between them. So this is the good conundrum for now, but the issue basically is not complicated. We need to choose raster from the main panel and go to the extraction where we will select contours. Contours can be extracted like this. Our input layer will be always interpolated. Band number remains the same. Important is interval between contour lines. So the interval is expressed in meter units, the same units which used for creating the grid and specifying density in between them. So let's go with 10 meters for now. Attribute name means the name of column in data attribute table which will represent the cutting. I think everything is fine here, so we can hit run and wait a while until the tool will make its job. When you are unable to see the contours, go to the layer and move this layer to the top. Now you will see what is happening in the area. We've got the contour cuttings by 10 meters, so it looks pretty much like this. It might be not enough, therefore I would recommend to repeat the option, go to the raster, where this time instead of 10 you will select 5 meters, making your contour cuttings twice denser, and hit run. Everything should be correct. So in this case we will see finally two sets of contour cuttings. One is 10 meters, another one is 5 meters. Obviously this one which is 5 meters is being overlapped by 10 meters in partial. So I think it's a good time now for defining some styling. So since we know which one is which one, because I think I should have to change the name of this layer even if the layer is scratched, but I haven't done it, so by correlation I need to figure out which layer, which one is which one right now, but it's fine. I can choose this layer here, go to the properties, and as the styling I can select, for instance, black line, dash style, and keep the stroke as it is, hit apply. For my main line I can use slightly different criteria, make the stroke just a touch thicker, keep color black and solid line. I think I could also enter the labels and define the labels for my layer. Select elevation column, and this is pretty much how my elevation data for this area should look like. So it's a brilliant situation that, as you can see, you don't need to use Google Earth for this purpose, but my aim was to get this elevation data not for this area but for the plot of land which is beneath. So I can switch the interpolation off and switch the waypoints off, and area which is covered by this elevation data is larger than the plot of land which I am interested in. So my very last step will be creating some scratch layer. It will be polygon layer where I will simply redraw the borders of this plot of land. Let me do it quickly. Okay, so I've got the polygon, but it's not everything. I need to change the styles. Just the quick changing. Make the color transparent and fill 0.6 maybe solid line. So I've got my plot of land. Alright, so the very last step will be using vector geoprocessing tools and intersection. Our input layer will be one of the contours, so I think this is the time where I need, unfortunately, to change the name of these scratch layers, like contours 10 or not 9, contours 5. And go back to vector, intersection, input layer contours 5, overlay layer will be new scratch layer. Input field, what I need to input, I can select them all, it's not a problem. Hit run, and I have the intersection, yeah, so it will be intersection 5. I need to repeat this process for my other contour cutting, contours 10, new scratch layer, transfer them all and hit run. I've got intersection 10. Yeah, so very last step is copying the style. paste style, and for I use all style features because I also did the labels, but for contours with cutting, with 5 meter cutting, I don't need to do like this. I can copy only the symbology and paste the symbology. And my very last step is to removing the contours, and as you can see, this is the final result of my work. I've got the plot of land. Now I roughly know which part of my plot of land is the lowest, which part of my plot of land is the highest. I've got 40 meters above sea level on the western part, and southeast part is slightly over 70 meters. So as you can see, you can extract the elevation into QGIS not with Google Earth. You don't need the third party like Google Earth to do it. The only thing you need to go is the GPS visualizer, which will provide this data for you. But using the initial algorithms in QGIS may save a lot of time, especially by defining the area on which the elevation data we need, unlike the Google Earth when we need to draw the path manually. So I hope that you enjoyed this video and you will learn something. Thank you for your attention.